Hello students, in this video we are going to discuss about the mechanism of nucleophilic addition reaction of aldehydes and ketones. As aldehyde and ketones undergoes nucleophilic addition reaction because the carbonyl group which is present in the aldehyde and ketones are highly reactive polar group, that is the carbonyl group. In this, it is polarized due to the higher electronegativity of oxygen in compared to carbon. Therefore, the electrons between the carbon and oxygen is slightly towards the oxygen because the oxygen is more electronegative than the carbon. Because of this, the electrons between the carbon and oxygen is slightly towards the oxygen atom. Because of this only, it develop a partial negative charge on the oxygen and it develop a partial positive charge on the carbon. Now, the reactivity of the aldehyde and ketone is due to this group, that is the carbonyl group, which having a partial positive charge on the carbon and the partial negative charge on the oxygen. So, greater the polarity of this group, greater will be the reactivity of the molecules, that is towards the nucleophilic addition reaction. Now, let us consider a nucleophile. Nucleophile that is negatively charged, that is electron rich species. Now, this nucleophile that is negatively charged attack the carbon, that is electrophilic carbon atom, which is partially positive charge because nucleophile is negatively charged and the carbon, that is a carbonyl group carbon, is partial positive charge. As we know that the positive will attack the negative because the opposite charges attract. So the nucleophile which is electrically negatively charged attack the partial positively charged carbon atom, and this attack is nearly, we can say that it is approximately perpendicular to the plane of the molecule. That is, if this is one plane, as we know that sp2 hybridized carbon that is having the planar geometry, that is trigonal planar geometry. Here this carbon atom is sp2 hybridized because there is two bond, that is a double bond between the oxygen and the carbon. So this carbon is actually sp2 hybridized. So here this molecule is in, we can say that they have trigonal planar geometry. That is a planar means all the two groups, the carbon and oxygen, are in one plane. So the nucleophile will attack approximately perpendicular to the plane of sp2 hybridized orbitals of the carbonyl group. So during this attack, we can say that the pi electron that is present between the carbon and oxygen get transferred toward the oxygen atom, that give rise to an intermediate, that is here now the hybridization get changes from sp2 to sp3. Now it form sp3 hybridized carbon is formed. Here the hybridization is changes from sp2 to sp3, that is due to the attack of nucleophile. Now you can see that the nucleophile is get attached to this carbon atom, is attached, and the oxygen is developing a negative charge. So this negative charge is formed as due to the attack of the nucleophile, the pi electron of that is present between the carbon and oxygen get transferred to the oxygen atom, that is giving rise to an intermediate. This is an intermediate having a negatively charged oxygen. The hybridization of the carbon changes from sp2 to sp3. Here the carbon is sp2 hybridized and here the carbon is sp3 hybridized. So the hybridization of carbonyl carbon changes from sp2 to sp3. Now this geometry is called as tetrahedral geometry. That is sp3 hybridized carbon, that is it have a tetrahedral geometry. So this is called as a alkoxide intermediate which is formed here. So it can be better explained this in this way. It is given in the textbook, that is the nucleophile that is attacking on the partially positively charged carbon atom, that is nearly, we can say that it is perpendicular, this attack is perpendicular to the plane of sp2 hybridized carbon. Then because of this attack, now it forms in the step 1 it form a tetrahedral intermediate which is called as a alkoxide intermediate. This is called as alkoxide intermediate which is formed here, that is having tetrahedral geometry. Now this intermediate, that is a tetrahedral intermediate, now it captures the hydrogen plus, that is H plus, it captures the H plus from the medium and it form a neutral addition product that is formed here. So this intermediate, that is the tetrahedral intermediate, it captures, we can say that the H positive ion, that is here it is negatively charged. You can see O is having negative charge. So the H positive can be easily captured and it form and product that is called as addition product. So now the product is ready. So this product is having a tetrahedral geometry which is electrically neutral. So this is what explained in the textbook in this way. A nucleophile attacks the electrophilic carbon atom of the polar carbonyl group from the direction approximately perpendicular to the plane of sp2 hybridized orbitals of carbonyl group as shown in the figure here. The hybridization of a carbon changes from sp2 to sp3 in this process, that you can see here. Now this is sp2 carbon is changed into sp3 carbon, that is in this process, and the tetrahedral alkoxide intermediate is formed in this process, and this intermediate captures a proton from a reaction medium to give the electrically neutral product that is shown here, and the net result addition of nucleophile and H plus across the carbon oxygen double bond is shown in this figure. So this is what the explanation that is given in the textbook. So the important point here is that the nucleophilic attack is taking place perpendicular to the plane of sp2 hybridized orbitals of carbonyl group, and here the hybridization changes from sp2 to sp3 in this process. That are the important point. So this mechanism is important to discuss the nucleophilic addition reactions. So in the next videos we'll be discussing about the nucleophilic addition reaction. So this is all about this video. Have a nice day.